Okay, so today we would first do the exponential function. So exponential functions. Uh, Perhaps you have already done what is um, linear equation or equation of line. Perhaps you know y is equal to mx plus c. Do you know that
C
equation of a
is
line?
M is the gradient
Yeah,
and C is y-intercept.
yeah, you are right. So normally, if it is a linear line, it goes like this. But the exponential function actually goes like something like, if I am taking from this, it goes like something like this. It means with every here, if you see which is a linear equation line, you have the same increase in y as is of x. Do you understand? If I say y is equal to 3x plus 2, maybe it's a linear equation. So with every one change in x, the y changes 3. Do you see that? Because rise over run. Yes?
Yep.
Okay, but it's not in the exponential function. So let me write the generic formula of the uh, exponential function. So generalized formula. So generalized formula of equation of the exponential function is y is equal to y naught a raised to the power x. Yes, and where a is greater than 1. This is 1. It can be less than 1. Do you have some idea of this exponential function or no?
Not really.
Okay, no worries. What is y naught? Y naught is actually the starting value. So, I mean, I can write something like this. Y is equal to 3 raised to the power x, right?
Yep.
If I write like this, so y naught is actually equal to 1, a is equal to 3. Do you see that?
Yep.
I mean, I can write another. This is y is equal to 1.75 times 8 raised to the power x. Can you tell me what is y naught in this equation?
Uh, so Y 1.75.
Very nice. And what is a?
A is 8.
Yeah, very nice. So this is like this, right? I just make a very simple exponential equation. Y is equal to 2 raised to the power x. So as you have done earlier, perhaps on what I say in maybe in some of the other forms, maybe in linear equation, or we put different values and we would see that. For example, if I put x is equal to 0, what would be the value of y?
Uh, it would be 1.75.
No, 2 raised to the power 0.
Oh,
I am taking this.
that equation.
Yeah, this is
0?
yeah. No,
No, 1. 1.
indices. Any number raised to the power 0 is
1.
1. So it is. Do you remember that? The
Yep.
the formula says, let me write it in red. A raised to the power 0 is 1. You remember that?
Yep.
Yeah? If I put this and this, can you tell me that what the value here for 1? We are having this.
1 is 2.
Yeah,
2 is 4.
good.
And then, is that 3?
Now 2 raised to the power 3. Oh,
2
sorry.
is
Yeah, I missed it. Sorry. Yeah, 3.
8.
Yeah. If you see now something very interesting, which I said, if it is a linear equation, which was this one, where I am putting, the change with 1 was always 3. Do you see here this?
Yep.
But here with the 1, here for 0 to 1, the change is 2. From 1 to 2, the change is 4. So for 1, the change is 4.
Mm-hmm.
Or no, the change is 2. So if I plot this graph something, so at 0, I should plot it a little lower so that, so just Control Z and here. So if I plot this, At 0, it is at 1. It should at At 1, it is at 2. At 2, it is at 4. And at 3, it is something at like this. So if I plot, it is going something like this. Do you see this?
Yep.
Although I have changed but so if we see, the change is much higher as for this one, as we are moving up in the exponential function. And this would be going like this. If I put -1, it would be 1 over 2. Do you see that this is 1 over 2?
Yep.
This is from the indices law. 2 raised to the power -1, that becomes 1 over 2. Remember?
Mm-hmm.
What would be at -2 if x is -2?
Will be 1 over 4.
Yeah, very nice. So it is. So if I see here and here, so this is an exponential function. We understand that, right?
Yep.
Okay. Um, so this was y is equal to. So this graph was for y is equal to 2 raised to the power x. Make sense?
Mm-hmm.
Okay. What we would do now, I would move to your book. You have the book with you.
Yep.
So we would see to it, and we would see what is. Okay, that's one thing which we saw. Let's do one more thing. I see this is something like exponential relationship. We would see how so we have said y is equal to y naught a raised to the power x, right? And where a is greater than 0.
Mm-hmm.
So this we would see few more things once I would go into more details. This last time or the previously, once I said the condition was, I just highlighted. The condition was a was greater than 1.
1.
And now this has changed. This is a is greater than 0. We would talk about it, that what effects this brings. But exponential, let's see what is the first thing which we have to see is exponential relationship. If I put uh, something like this, let's say um, we have an exponential function. It has a value 3, 6, 12, 24, and 48, and 96, right?
Mm-hmm.
So if you look at it, there is something which we found. If you look at the first difference means first difference, first difference. So what is the difference between 6 and 3?
3.
Then 12 and 6.
6.
Next,
12.
yeah. So this difference
24.
is not constant. It is non-linear. Do you see it is? So it means this is not a linear equation. This values, if we plot, this is not a linear equation, not linear. Do you see this or no?
Yep.
So this is called, it's a not a linear. But then there is something very interesting which we see. We divide 6 by 3. What is the answer?
6. 2.
12 by 6.
2.
24 by 2.
2.
Oh, what does it
Oh,
mean?
24 by 2.
24 by 12, sorry.
Uh,
Because we are looking at these values. 24 by 12 is also 2.
yep.
So what we see there is a constant ratio. It's not, difference is not, but the constant ratio. Do you see that it's a constant ratio?
Yep.
And if it is a constant ratio, then it's a exponential function. You understand that?
Yep.
And if the difference is constant, then what type of function is that?
Exponential.
No, no, no. If the
Uh,
difference, the first
if,
difference,
if the first difference
constant, the
is
same,
linear.
then it's a linear. Then it's the equation of line. Do you understand this or no? Should I explain it again?
I understand this.
You understand. That's good. That's good. So, so if we write y is equal to y naught a raised to the power x, where a is greater than 0, then we are saying what would be the value once x is 0? When x is equal to 0, can you tell me what is the value of y? This is
Uh,
just
it will be equal to y naught.
very nice, because a raised to the power 0 is 1. So it means it is giving us the value at x is equal to 0. Yeah? For
Yep.
example, if I say y is equal to 3.5 into 4 raised to the power x, can you tell me what is the value at x is equal to 0?
What is the value of x?
At
If
x is equal to 0, like this.
3.5.
3.5. I just put very quickly, I do not ask you, rather I put the values. So if it is 0, it is 3.5. If it is 1, it is 14. If it is 2, it is 56. If it is, sorry, if it is 3, it is 224, right? And if it is 4, it is 896. You can use your calculator to find it. But why I'm trying to do this ratio, let's see the ratio. So if you see 14 divided by 3.5, do you have a calculator?
I have my class pad with me.
Yeah, you can use the class pad. That's the same thing.
14 divided by 3.5. 4.
Yeah, very nice. What about 56 divided by 14?
4.
Yeah, and 224 divided by 56.
4.
Yeah, what does it mean? This means it's
It's
an
an
exponential,
exponential.
exponential function. We understand that, right?
Yep.
So, so what is the characteristic of an exponential function? It goes something like this, right?
Hmm.
But this is not very correct what I said. This goes like this if a is greater than 1. What this a? Yeah?
Yep.
Okay. So we would now look at few things, which is, so it says this is like a growth. Maybe it's a population of a country increasing like this, or perhaps, in the COVID time, it is like they say how the virus is increasing if you allow the people to mingle. Do you understand this?
Yep.
And therefore the countries are going into lockdown and something, so that they are not gone like this. You understand that?
Hmm.
Okay, we would just say a few things. So exponential growth. What I say, exponential growth. Exponential growth. It means the things are mm, exponential growth. So exponential growth are is characteristics by this equation. Y is equal to y naught a raised to the power x, and the condition is, and I write this in another color, the condition is a is greater than 1. Do you understand this or no?
Yep.
It means it would going down up. Exponential decay, I would write it in another color. Exponential decay. What is meant by exponential decay, you think?
It's going from on the left of the graph, on the left of the y-axis, it's going coming down.
Yeah, that's very nice. So it would be ax, and where a would be between 0 and 1. Yeah.
Hmm.
So if I have to draw this thing, we can draw it afterwards. So it is something like a, you say, okay, a is less than 1, and I put any values. So for example, let me see, draw it. So if you have something like this is y is equal to 0.5 raised to the power x. Can you tell me what is this value here?
Uh, It's 1.
1, good. So if I just draw this and I take another color for this, y is equal to 0.5 raised to the power x. Just quickly, I put few values. So I put few values with your help. Oops, just move it a little. Okay, so we say it if it is Control Z, so it is x. Just a minute. I would just move it x and y. So you already that at 0 it is 1, right?
Yep.
So if I put this as a 2, a 1, sorry, so at 1
If you
it would be 0.5. What would be the value at 2?
2 would be 0.25.
0.25. And we do not go. And minus 1,
So,
if you
so
put minus 1, it goes 1 over, so it would be value would be
2
very nice. So if we see it's going up, and minus 2 it would be,
minus 2 would be 4.
yeah, we understand that also. Because, and if you look at the ratio, I can even say this without calculating because we know the ratio is zero point 0.5. Why? If you see here, zero point 0.5 divided by 1 is actually 0.5. This is the ratio, and this was the ratio which was here. So everywhere I can see 0.25 divided by zero point 0.5 is 0.5. 0.5 divided by 1 is 0.5. 1 divided by 2 is 0.5. You see this?
Yep.
2 divided by 4 is 1 over 2, and that is zero point 0.5. You see that?
Mm-hmm.
Okay.